Topic 7.1 Summary, Part 1, Discrete Energy. When you look at a rainbow, you see all the colors that make up visible light. We call this a continuous spectrum. If you shine sunlight through a prism or a diffraction grating, you'll also see a continuous spectrum. However, if you get a gas such as hydrogen or neon hot, it will glow, giving off light. If you then shine that light from the glowing gas through a prism, something very interesting happens. Rather than seeing a continuous spectrum, we see discrete, bright lines. We call this an emission spectrum. But what's going on here? Light, of course, is a form of energy. Light consists of bundles of waves called photons. The amount of energy a photon has is directly proportional to the frequency of the light and can be calculated by this equation. The proportionality constant in this equation, h, is called Planck's constant and is equal to 6.63 times 10 to the negative 34th joule seconds. In 1913, Niels Bohr hypothesized that electrons in an atom are constrained to certain orbits or energy levels. In order to move to a higher energy level, a photon of a particular wavelength must be absorbed. When an electron returns to its ground state, a discrete amount of energy must be emitted as a photon. But what does this mean? If a photon striking an atom has an energy exactly equal to the difference in energy between one energy level and another energy level, a higher one, then the photon will be absorbed by the atom and the electron will jump to the higher energy level. When an electron falls from a higher energy level to a lower energy level, a photon will be emitted. The energy of the photon will be exactly equal to the difference in energy levels. Therefore, the frequency and corresponding wavelength can be calculated by E equals hf. So an electron in an atom can't have any amount of energy, but it's rather constrained to certain energy levels. We can make an analogy to the block in this picture. In the top picture, if the block moves up or down the ramp, the block's potential energy will take on all values in between its maximum and minimum value. We could say that the potential energy of the block is continuous. In the bottom picture, however, the block is moved up or down a staircase. As the block moves, its potential energy is constrained to certain values which depend upon the height of the step. To make this analogy work, we have to ignore the transition between steps. So in topic 7.1, we learned that energy is discrete, but just what does this mean? Well, it means that the energy that an object possesses comes in certain particular values. It can't have any old value. And so the question comes up, why don't we notice that energy is discrete? And the answer is that the steps are very, very tiny. So by analogy, if we think about water, so the question is water discrete or continuous? So when you pour a glass of water, it appears to be a continuous substance. But what you already know about water is that it's made of molecules. So water's lumpy. When you're pouring water, it's actually individual molecules that are being added to the glass. So if you think about the amount of water that can be in a glass, there are not an infinite number of different amounts of water that you can have in a glass. It's limited to the number of molecules. And so, of course, why don't we notice this about water? Well, molecules are really tiny. Okay, that's it. See you next time. Although I do have a wacky definition for you. Today's word is arbitrator. An arbitrator is a cook who works for Arby's, who then quits to work for McDonald's.